So let's just see what happens in shallow lakes. Okay, and have a look at the top image. Okay, so you have a shallow lake, and you have a situation of a very strong wind stress. You have a strong wind event blowing from right to left. Okay, so let's activate the laser. Here, the wind from right to left. And what happens is that the wind pushes water over to the left side of the lake, pushes the water level up on one side, and on the other side pushes the sea level down on that side. Okay? And this slope of the sea surface actually produces a pressure gradient force in the opposite direction. Okay? And now the superposition of the wind-driven flow and the pressure gradient-driven flow actually gives you a circulation where you have a surface flow into the wind direction and you have an undercurrent opposite to the wind. As a consequence, on one side of the river you have upwelling, and on the other side you got downwelling. Okay, and this is the typical situation that you have, for example, in Flinders Lake. You know, if you have a strong wind, you get an overturning circulation. Okay, with upwelling on one side, downwelling on the other side. So now, what happens if you are in shallow water, but now in the ocean, and you're in a semi-enclosed sea like the Arafura Sea, where you actually have one end open? Okay, so now you have offshore winds. This is now shown here in the second graph. Strong offshore winds. Okay, again, you trigger upwelling, and this upwelling is actually called the Lee effect. Okay, you create a offshore flow in the surface layer and an undercurrent underneath. Okay, so what can happen in this situation that you can actually import nutrient-rich water into that area. So this one is in the Arafura Sea example, the Banda Sea. Okay, and you can bring in this water as part of the undercurrent and upwell it to the surface. Okay, and this all because you have overlapping Ekman layer, which eliminates the Coriolis force. Okay, so in effect, you don't have a Coriolis force. That's why you have that very special type of circulation. You don't get this circulation anywhere else. Okay, so let's now focus on the Arafura Sea and what happens in the Arafura Sea.